Okay, you can hear me? Well, I think I guess I'll just speak on behalf of myself for a moment. So I'm very honored to be doing this, the conference summary together with Jason here, who I presume is also equally as honored.
Oh,
It's the trick.
Click because I think with most on the Zoom.
okay. You're doing great.
Oh, good. Okay, so I think big caveat here, it's really there's so much has been presented. I mean, I don't know if I speak for some of you also, but I'm like overwhelmed how much fantastic science and how many fantastic people there are in this field. It is inspiring, it is rewarding, and it's energizing. And there's no way we're going to be able to summarize all of your results. As much as we'd like to, we've taken copious notes. And so we're aware of all of them, but we have a short amount of time. We can't do everything. So Jason and I put together some highlights. And I'm sure as I go through these highlights, are we doing this together, or you want me to we want to alternate, or do you want to?
You do this one and then we'll.
Okay, fine. And I'm sure as I go through these, we'll be like, oh yeah, we forgot blah, but that's just how it is. You know, the ultra wideband repeater detections are super interesting. All the repeater stuff is amazing. Each repeater seems to be telling a different story, which is making me nervous. But it's interesting. The time evolution of repeaters, so never mind just like collecting all the births, seeing how they evolve in time. They each seems to evolve a little differently. And I'm going to come back to that point a little later. Like the variety of types of repeater or possible variety of types of repeaters. The high precision localizations you've already heard are becoming just normal. It's when you think about how you are going to localize precisely a millisecond duration event that you don't know where or when it's going to happen. That is just shocking development, and I think it's amazing that this is now possible. Population of FRBs and globular clusters. Well, I don't know if we have a whole population. We have certainly one, maybe two. Are there others? Did I miss something? I don't know about this. Anyway, maybe.
I think Alexa showed that like there could be more. Probably three.
Yeah, okay, you're right. That's a population.
Yeah, three is.
Well, look, this is better than gamma ray astronomy, where like it's one photon's detection and two photons is a spectrum. Okay. And then the missing baryons. They're not so missing. We were gonna have to stop using that. They're like the found baryons. But where are they? So it's a little bit like Waldo, but except we kind of know the general vicinity. But now we're getting into some interesting astrophysics that can that spills over into a whole variety of astrophysical fields. An FRB at redshift greater than 2. Like, I don't think anybody's surprised that exists, but isn't that nice? We're getting out there. We're getting there. I think that's just beautiful. Now this is like, we're really jumping around in topics here, but the explosion of long period transient discoveries, and we're going to shortly have a bitter argument about this.
An argument. So.
Yeah. Correlations with large scale structure and halos. That's the combination of the missing baryons, localizations, high redshift. All of this is being combined into doing some fantastic extragalactic astrophysics that some of us pulsar astronomers never dreamed we'd ever do. And then, of course, today with the amazing, fantastic instruments and facilities that are coming online. We've listed a few, but I'm sorry if we missed your favorite one, but we are aware of it, and I think all of us are aware of fantastic experiments. So these are some of the highlights. Let's see if I can actually change the slide. Okay, some thoughts on science. I thought that one thing that was amazing is so many young people that were highlighted at this conference. The conference really did highlight the youth and the future of the field. And I thought there was a huge, but with meaningful content and a huge spectrum of complexity in the slides. There were some that were so pedagogical that were really fantastic for those who are entering the field, and then also some really meaningful complexity. And I thought I'd just show a sample of that. I really loved this slide, particularly the warning that it's not drawn to scale. Thank you for that. And then on the other end of the spectrum, so we covered the gamut in complexity here. So that was impressive.
I can't even read it from here.
Yeah, yeah. And then, you know, okay, so just looking back a little bit, we started the conference with a little history, and, you know, the minor point, FRB is a minor point of interest. I just still love that. I want to remind all of you so that you can go out and tell your deans and your chairs and your departments that, you know, astronomy is the only branch of science for which the 101 textbooks still need constant rewriting. You know, we are really developing knowledge in this field that is fundamentally different from in other scientific fields. A lot of this is happening in radio astronomy. You are witnesses to that. You're going to look back on this time as a golden era. And it's really driven by huge advances. I mean, in part, driven by huge advances, piggybacking on commercially motivated computing advances. But the FRB field is just a perfect example, and you're in the middle of it. I remember a time when these things, we didn't know they existed. You know, it was a shock. And you all are living with it like yeah, they exist. But anyway, you know, the discovery of FRBs was sort of serendipitous, but not really serendipitous. You know, we heard in this meeting, I didn't know this, that theorists anticipated using radio signals for detection of the missing baryons back in 1965, before even pulsars existed. So did they imagine you could have luminosities like FRBs? I don't know. I don't think they did, but it took, and I really felt we had to show the, you know, the official discoverers. Of course, there was a team there also, but the ones who were recognized, and we have Dunk. Is Dunk still here? Where's Dunk? Yay, Dunk. Yay. Thank you. But the discovery of repetition, of course, was not serendipitous. That took patience, time, diligence. There's a lot of people, myself included, who were kind of skeptical of these things. We didn't really think they repeated. It took a long time to find those repeats. So young people take note. And on that note, happy birthday to FRB 121102, little birthday party. Did you want to say anything about that also? Just
a little birthday hat.
Yeah. Did you do that?
Yeah, I spent a lot of time on it.
And yeah, so, you know, we can single out individual people, but I love this slide. I really love this slide. It is a group effort. So every one of you is playing a huge part in this, and it's not always obvious, and it's not, you know, it happens in fits, and in this meeting is this, and this meeting is that, but everybody, we probably have almost every person's name on this slide. Yeah, and you know, it just keeps growing. I just, you know, did for fun ADS search fast radio bursts. It's rising, and you know, the future is FR bright. Oops, yeah, sorry. And you know, you can compare that to other things. Magnetars also rising, not as steeply. Radio pulsars kind of flattened out. I think that is going to start growing also. The same surveys that are looking for FRBs, like, you know, CHIME, and we're going to have CHAMPS, a big survey that is going to find lots of pulsars, and you know, DSA, there's going to be lots of ways to find new pulsars. That's going to start rising again soon, I predict. We have a ways to go. On the y-axis, you'll know galaxies, a lot more galaxy stuff. And just to normalize, I just searched for something random, banana.
We're only doing we're only doing a factor of 10 better than bananas. Yes.
I think that's X-ray astronomy. There are banana plots, is the color diagrams for X-ray binaries. I know this, so, but I wasn't thinking anyway. Okay, so two big mechanisms that we hear about for progress in the field. I'm sure there's others. You know, doing large surveys where you need large numbers of sources, but you have to be really systematic about it if you want to understand populations and essential things like luminosity functions, redshift distributions, correlations. All these things are going to reveal what these things are and how we can make use of them as cosmic probes. You know, we have to understand our instrumental biases. And I thought I love this slide from Kyle, but it's an example of what everybody has to be doing. We have got to understand if DSA is going to find 25,000, I forget how many, and court is going to find 10 billion, I forget how many. But we're going to have to do this kind of work. But on the other hand, the easier stuff, the stuff that I just love doing is because it's so much easier, is you still need large numbers, but you don't have to worry about all the bias stuff. And each source tells a key story. So you just find one galactic magnetar that makes an FRB. And suddenly, boy, tells that, you know, that just, it speaks 1,000 words. And so all these experiments, Y-field experiments, we're hearing about BURST and GREX and all these others, they're fantastic. And I think hopefully we'll start finding more of those. But then you see all these other sources that are really amazing that we found. And, you know, just if we could find one real periodicity source, like what Barak and Dotan are looking for, that'd be awesome too. I just have to comment I'm just struck by the variety of repeaters. We have one, maybe two that are periodic. You know, some are hugely active, some are not. And I love this as a plot. You didn't see at the meeting, but you should have, because this is a weather report Ziggy Plunis makes for the CHIME collaboration. You see, this is declination here, this is year here, and you see each one of these is a CHIME FRB repeater, and you see some just don't shut up. They just blah, 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 blah. Some, you don't see them for years, and then, my goodness, they go off. So what is that? You know, there's just a huge range of activities. You know, some have been localized star-forming regions, and some are in globular clusters, and some have microstructure, and some do not. Some have huge RMs, and some do not. And then you see these fantastic work by the FAST telescope, Meerkat, and others doing ASCAP, doing detailed studies of individual repeaters. And, you know, I took the button N populations of FRBs. But sometimes I think maybe it's N populations of just amongst the repeaters, there's different populations. Just don't, you could throw things out. I wonder. Okay. Okay, now we get to.
Oh yeah, the argument.
Yeah. Okay, galactic analogs. You know, LPTs, are they relevant to FRBs? That's the question. And
Totally.
What? What?
Totally. Yeah.
Yeah.
Totally.
So Jason says, yeah. Oh, yeah. So Jason says, sorry.
They're totally relevant.
Okay.
Yeah.
And I'm saying no way, except for magnetars. But what I'm trying to say is, you know, the LPTs, and I have lots of, in fact, I'm using too much time, but I think LPTs are fantastic. I mean, I love LPTs, but are they relevant to FRBs? Like an LPT is like this. And an FRB destroys the block. Those are different things to me. Please.
You're right, but you're also wrong. In the sense that it's true of pulsars as well. Radio pulsars are little pipsqueaks compared to the extragalactic FRBs, but they showed us that neutron stars can make coherent radio emission. So when we found the magnetars showing coherent radio emission, we already knew a lot of stuff because of pulsars. And I think the LPTs are showing us that there are other types of objects like white dwarfs that are in binary systems magnetically interact with another star. And I agree, you know, at extragalactic distance, there's no way we're going to see this, but maybe there's a ramped up version of this that we can see at extragalactic distances. So it's a proof that we should be more creative in terms of what we think can make coherent radio emission.
Yeah. So I just think, you know, it's just a bias because we're in a galaxy. And so these things look the same in our telescopes, but it's because some are right here and some are, you know, on Mars. Okay. Agree to disagree.
Okay, that didn't get too ugly, actually. Yeah.
Yeah, LPTs, they're so interesting. There's such filling out the Death Valley. You know, I remember when the 8-second pulsar was found, it was 8 seconds and we were all, and now we're hours? Like, what is that? And I can't help but wonder, is this like the early days of FRBs? You know, we have a few dozen and maybe some are microwave ovens, like we better check that. But will we have more than 5,000 LPTs in just a few years? And will there, you know, different classes of LPTs, and will we have buttons for LPTs soon? Maybe. And the same telescopes that are going to open up the field of FRBs for a lot of the science we heard are fantastic for this too. And then the environments, again, diversity in the environments, it's getting a little scary. You know, you see this slide and you're just like, wow, the only way we're going to answer this question is through big numbers and starting to find, are there different classes or is it one class that's distinct? I love this slide. I thought this was, this really summarized a good portion of the field.
How are we doing on time? We should probably finish it in 5-10 minutes, right?
Yeah.
Okay, so I have a few thoughts to complement what Vicky said. I was really astounded by the quality of the data that we saw at the conference, like really striking data. And I'm really looking forward to the data release that will come from this. I hope that's coming soon. We'll see. We have seen, as Vicky was saying, we're starting to get evidence that maybe not all repeaters are the same. I think one of the good pieces of evidence for that is this small emerging population of PRS sources. We have, 3 now that have high rotation measures that are variable. They have kind of flat polarization angles that are constant. They have these bright PRSs, and they're also in low metallicity dwarf galaxies. Really excited to see how that develops and whether this is more than just like some kind of evolutionary chain and whether these sources are like actually qualitatively different. As Vicky was mentioning, we're entering the regime of high precision localizations. And this means that we're actually pushing optical telescopes to their limit. I think a lot of us in the room are really excited about seeing what ELT will offer for the field at the end of this decade. But we saw from Mawson's presentation, this beautiful JWST data leveraging the chime outriggers position of this particularly bright and nearby, apparently non-repeating source. This is giving us like the first view of, okay, what does a non-repeating environment look like if you zoom in closely? And it looks radically different than the type of environment that we see from those PRS sources in the last slide. I mean, if there was a PRS here, it would be whoppingly bright. One of my favorite moments from the conference was when Benito welcomed Chime to the milli-arcsecond club. And I could feel Matthias kind of like glowing or something in a seat or whatnot. Yeah, so this is what I imagine was going through your head at the time. Loved Liam's talk, one of my favorite talks from the conference. I think it's fantastic that we don't need to talk about missing baryons anymore. We're talking about the hard problems of where are these baryons, what fraction is where, what state are they in, and we've seen some beautiful demonstrations both in Liam's talk and other talks, like for instance, just to name one example, Hao Chen's talk this morning. Ilya, also loved your talk. I think it's also fascinating that we're really starting to quantify the magnetic fields in halos, intervening halos along the line of sight. And during your talk, I must profess, I started kind of not drifting off, but I started thinking a little bit more creatively about, like, who else is seeing these FRBs? This is like my wacky slide. No, don't you look a little bit worried. You look a little bit worried. But I was kind of wondering, like, we can see these are like millisecond duration radio flashes. They're traveling for billions of years across the universe. They have some beaming angle, right? So they must be hitting other planets as well. And there's like other grad students. They have their own like chime or whatever they call it on their planet. And they detect these things. Maybe they detect them billions of years before we do, or millions of years after we do. The same FRB, and they'll see a different DM and whatnot.
Yeah.
Is Matt McQuinn still here? Yeah. Okay. Yeah, they look a little bit hungry. Yeah. Yeah. I think a lot of people really like the talk that Jacob and Ayush did, showing how observatories can work together. There are many ways in which this is possible. I think Omar emphasized in his talk as well, like how valuable ATELs are and GCNs, as we heard today, are for the community. If you think about it, there were a huge number of talks at this conference that were really based on following up a source that someone learned about from another telescope, be it Meerkat, be it CHIME, be it DSA 110. We have to keep doing this because we're going to be a lot stronger as a community if we combine these telescopes. And I guess the last things that I'll say about the science, this field is really accelerating. About 2 decades ago, we had the Lorimer burst, and We're starting to go down this iceberg. I think because of telescopes like CHORD and DSA 2000, we're going to dig very far below the waters that we currently know about right now. And I'm really excited also to see what that means in terms of exploring a multi-dimensional parameter space. We've seen many times in this talk, for instance, you know, the luminosity versus timescale plot that people show for the parameter space. But of course, as I think everyone knows, that plot, it buries all the information about radio frequency, bandwidth, about occurrence rate, polarimetric properties. As we explore these other dimensions, we're probably going to find qualitatively different types of objects. Yeah, so just a few very brief thoughts on the conference. I really like that we had the pedagogical day. I think if this field is going to blossom and if we're going to be able to deal with tens of thousands of FRBs per year, we're going to need to continue growing the community. One way of doing this is to make conferences accessible to people who are new to the field, that they can feel like they can hit the ground running and learn new things. Amazing visualizations during that pedagogical day. Like these are just some examples. Yeah, like really applause on these. Yeah. Like it's hard enough giving an instructive talk. I mean, like creating these visualizations just makes it, oh, mwah, chef's kiss. Very good. Beautiful. Hybrid conferences. I'm super happy that we were able to double the capacity of this conference by having people joining on Zoom and YouTube. Liam had this amazing cartoon of his little face on a laptop there on a whitewater rafting trip. Yeah, this is what makes these conferences accessible, and it means that our community can expand to countries or institutes that do not have the funding to just go across the world for a conference. In case you've forgotten, all of the talks are going to be available on YouTube, and we've repurposed the YouTube channel that was used for the conference that was online in 2021. So by doing this, you know, you'll be able to review some of the talks from the conferences, and I think also importantly, we're starting to build up kind of like a historical record of the field's development in the last few years. Likewise, and I think this is the last thing I was going to say, we have this community Slack workspace. It is funded by a number of the people in the room. So this is like a professional account, an educational professional account. That means that the messages don't disappear. Feel free to create private channels there to like collaborate on papers and whatnot, or to reach out to people. We have 768 people who are members of this Slack workspace, and I think it's a very valuable tool. So Vicky, please take it away with the thank yous.
Yes. Okay. So first of all, thank you very much to the funders. And I'm really glad a lot of you got to meet one key funder at the banquet, but there's lots of other funders. So thank you for all of that. Thank you to the scientific organizing committee, especially, I mean, I noticed really filled with young people, and there were some people there just for age diversity. But it's I thought it was a very, very good program, and especially I want to thank this amazing local organizing committee. You know, every one of these people is a world-class researcher, and, you know, watching them, you know, schlep falafel around for the conference was really amazing. And I think we should give them all an enormous round of applause. I mean, the organization was phenomenal. And the inclusivity was really, really beautiful. There was a clear vision here of how a conference should run, and I think they really accomplished that. And so special thanks to the chairs of the committees, Amanda Cook, Banting postdoctoral fellow, and Alice Curtin, SKA, Canadian MBA scientist. A special round of applause for them.
So we have flowers for you. We each get a can of maple syrup. And to help burn off the maple syrup, there's something in here. Yeah, I'll leave it at that.
And I guess, so this is, unless Yeah, is that the last slide? Is that the last one?
That's a lot.
Okay, so then, but I do think we should also thank all of you for coming, participating, being so engaged and so energetic and so full of life. And you all traveled from, or some of you traveled from really, really far, and we really thank you for that. And we look forward to the next time we get together at FRB, I guess, 2026. 2026.
I guess I would just say it's been absolutely incredible hosting you all here at McGill. And also as early career researchers, you have made the process of us hosting this absolutely fantastic. This field is so welcoming and supportive. And I think the growth and cross collaboration we're starting to see is really inspirational from a young researcher's perspective.
And thanks to Vicky and Jason for ending on such a high note, and we hope you all get home safely. Thanks so much.